Will Japan's sixth-generation fighter jet ever become a reality? In the first half of the 21st century, the world will be unstable, and its upheavals will increase. The conflicts on the Gaza-Israel border, the war in Syria, and the tensions over Taiwan created by China are creating a tense atmosphere. There's a large-scale war in Ukraine, almost in the center of Europe. In this situation, Japan feels uncomfortable. Russia, China, and North Korea are three aggressive totalitarian countries with nuclear weapons that are close by. Therefore, Japan's decision to have the most modern weapons is extremely logical. One of the main elements of this armament would be its own sixth-generation fighter jet. Today, we'll look at the Japanese program to create such an aircraft that'll be able to compete with the Russian Sukhoi and Chinese Chengdu. We'll talk about the interesting aspects of this program and find out why Japan has moved directly to developing a sixth-generation fighter without stopping at the fifth-generation machine. Let's start with the last question. In fact, Japan is continuing to develop its fifth-generation fighter jet, which it's been working on since 2004. To date, only one prototype made its first flight on April 22, 2016. This fighter has one pilot seat, a wingspan of about 9 meters, and a length of 14.2 meters. The weight of the empty machine is about 9,700 kilograms. The size of the new Japanese aircraft resembles the Swedish Saab Gripen light fighter, and its shape is similar to the American F-22 Raptor. The size and angle of the Japanese fighter's vertical winglets, as well as the shape of the inlet and outlet air intakes, are identical to those used on the fifth-generation American fighter. In 2005, the Mitsubishi X2 glider was tested for radar visibility. A representative of the Japanese Ministry of Defense noted that the effective scattering area of the prototype is larger than that of an insect, but smaller than that of a medium-sized bird. This means that detecting such a prototype on radar will be very difficult. It's known that the fighter is equipped with 2 turbojet engines and is capable of reaching supersonic speeds without the use of a thrust amplifier. The prototype is equipped with the IHI XF51 engines with thrust vector control, and 3 pedals on the nozzle of each jet engine are responsible for deflecting the jet stream. Thus, Japanese engineers have made significant achievements to accomplish such a complex task as the creation of a sixth-generation fighter jet. Interestingly, the Mitsubishi X2 was created thanks to the Americans. More specifically, it came about as a response to the way the Americans restricted Japan's access to their technology. When the United States was developing its famous F-22 Raptor, the world's first invisible fighter jet, Japan, as a loyal ally, hoped to receive a certain number of these aircraft. But suddenly the U.S. Congress banned their sale because there were fears that the technology used in the F-22 could end up in the hands of the Russians and Chinese. Feeling insulted, the proud descendants of the Japanese samurai decided to create their fifth-generation fighter jet. This is how the Mitsubishi X2 was born, and it immediately became a scandal. The Japanese military unexpectedly stopped funding a project aimed at developing a prototype aircraft that would then be put into mass production. The reason was the high cost of the project, which Mitsubishi Heavy Industries estimated at $215 million for the prototype. Instead, the Japanese military purchased American F-35 fighters for $219 million. This caused an outcry from Mitsubishi Heavy Industries, but the scandal was smoothed over by a promise to make them the main developer of the sixth-generation fighter, designated as the F-3. The cost of this program is $45 billion, but the Japanese military considers it justified. Now for the technical characteristics of this new Japanese aircraft. Although it'll be based on the Mitsubishi X2 technology, its appearance has not yet been determined and is still at the conceptualization stage. However, some information about its main characteristics is already available. For example, the fighter will be equipped with 2 engines, probably XF91 with a deflected thrust vector, and thrust at a break-even speed in the range of 15,000 to 16,500 kilograms each. By comparison, this can be considered similar to the thrust of the Predator engines. The F-119 PW100 engines used in the F-22 Raptor, developed by Pratt & Whitney, have a thrust of 15,876 kilograms. This is comparable to the Russian AL-41F1 engine, which is used in the Russian 5th-generation Su-57 fighter jet and has a thrust of 15,000 kilograms. However, the Russian side claims that it intends to put a new engine on its Stealth, mysteriously named Product 30, with much more thrust. In general, Japanese engines cannot be considered something exceptional, especially for use in a 6th-generation fighter jet. However, an even more interesting aspect is the F-3's ability to generate 180 kilowatts of electricity, which can be used to power combat laser or electromagnetic weapon systems with direct action, which are capable of destroying enemy electronics at a considerable distance. In addition, the fighter will have 6 internal suspension points for standard weapons. The aircraft will also have 6 ASM-3 anti-ship missiles located inside the fuselage. The ASM-3 has a speed of more than Mach 3 and can hit targets at a distance of up to 400 kilometers. Frankly speaking, with the advent of hypersonic weapons, these characteristics are no longer so impressive. However, as they say, it's too early to tell. We hope that Japanese developers will surprise us. Of course, $45 billion can work wonders. In addition to advanced weapons, the Mitsubishi F-3 will receive powerful onboard equipment. Firstly, it's planned to use a human-machine interface to control the aircraft, which will optimize the data flow and facilitate piloting and combat missions. Secondly, the aircraft's bodies, which act as radar antennas, will also generate electronic interference. The Mitsubishi F-3 will feature a high-speed system for processing and transmitting data from all surveillance and guidance equipment, including powerful ground-based radars. All these systems will be built on components that can withstand high electromagnetic pulses. The data will be transmitted via optical fiber, and the aircraft control system will automatically compensate for signal loss. The 6th-generation fighter will undoubtedly be a fighter with reduced visual and radio signature. Earlier, we discussed that the effective scattering area of the Mitsubishi X2, according to the Japanese Ministry of Defense, is equal to that of an average bird. As for the F-3, there's currently no information on this figure. However, there is information that Japanese engineers are planning to achieve invisibility with the help of revolutionary technology. In modern stealth aircraft, invisibility is achieved through a special coating that absorbs radio waves, as well as a special shape of the fuselage that directs the scattered waves in the absence of radar echoes. It should be noted that this works effectively in the decimeter, centimeter, and millimeter ranges. However, for meter-long radio waves, the aircraft remains visible. However, Japanese engineers are planning to use a material that can transmit radio waves, which sounds pretty fantastic. Frankly speaking, it's not yet clear how exactly they plan to achieve this. In addition, the plane will be equipped with a plasma antenna that can generate plasma and change its physical properties to absorb long radio waves. According to experts, this will make the aircraft invisible even in the meter wave range. Each F-3 will be able to control up to 3 drones, which can be equipped with reconnaissance systems or missiles. These drones will improve the offensive capabilities of the aircraft, but this is not new, as Russian developers have built and tested stealth drones such as the Su-70 for their 5th-generation Su-57 fighter jet. Each Su-57 is capable of operating 3 such drones. An innovative solution is the use of an interesting technology for connecting airframe components. Japanese developers plan to use glue instead of traditional rivets. This will reduce the weight of the structure and increase its rigidity. There's currently no information about the use of artificial intelligence on board and the possible absence of a pilot. Probably similar to other countries' 6th-generation fighter jet projects, 2 versions will be developed in parallel with and without a pilot. Write your opinion in the comments below. Also, don't forget to give us a thumbs up if you enjoyed the video. If you don't want to miss new stories about modern weapons on our channel, subscribe to it.